ETL's talk is really connected to our next talk about metrics that we're gonna discuss. So let me add Yishai to the stream. Just before we talk, just a sec, I just want to remind everyone that if you have any questions about any of the talks that we had today, please ask them in the Discord, and we're gonna have the Q&A panel at the end asking all of your questions. So Yishai, what's up?
Hey,
Yishai.
How are you?
Hey, I'm good. How are you?
I'm good.
So you're CTO at LinearB. Care to comment what's the...
Yeah, so LinearB is a startup that deals with helping development organizations, teams that write software. And our mission is to help them deliver better, help them improve the way they think about software delivery, and eventually be happy.
Mm-hmm. Cool. So you're going to talk to us about cycle time, which is a metric that not everyone knows about and could really help people understand what's going on their systems?
Yep. The most important metric you can think about.
Awesome. Okay, so take it away.
Thanks. So if you can afford to measure just one thing in your engineering organization or in your dev team, it should be cycle time. And I'm going to spend the next 15 minutes to talk about cycle time, why it's so important, and how you can win with cycle time. A little about myself. So like Hila said, I'm with LinearB. We are a pretty young startup. We've just announced a large round A, and our mission is to help dev orgs improve the way they deliver software. This is all about software delivery intelligence, which is the sum of the methods and approaches and technology that helps dev teams become elite performing teams. So you want to be data-driven. You want to have something to base your understanding of how your most important team works. Your most important team is your dev team. And like ETL mentioned earlier, you want to be very swift about delivering value all the time. You want to go through that cycle of write some code, get it in the hands of customers, learn and improve. So you want to measure things. But engineers are in many ways like artists. Writing code is a creative process. It's very hard to measure the muse, or it's hard to measure the output of a specific engineer and hope that that will actually get you somewhere. So maybe you're thinking about, how do I start measuring my dev work? Or you could already be doing some measurements, but you're measuring the wrong things, like velocity or lines of code. You're comparing your engineers one to another and maybe killing the culture. So what I'm going to just suggest here, and this is based on a lot of research, not just ours, is to move your focus from measuring engineers to measuring the team, to measuring the process, understanding the process that gets code from an idea to a working product, and look at the main productivity killers that really hamper the way engineers and engineering teams work. These are context switches. Everyone knows that if you want to work on something that is creative, that is maybe difficult, that needs brain power, you want to be in the zone. And interruptions, these could be instant messages or other tasks. Any kind of context switch is really going to drain your ability to promote the important things, and is also going to make your life more miserable. A work in progress culture, focusing on many things at the same time, having too many balls in the air, starting to work on things instead of getting things done, is another productivity killer and another cause for, oh, we did so much, but nothing actually made it beyond the finish line and actually created value for the company. And then there's dead value. If you think of it, when you're writing code and eventually merging into your code base, but if that code is not deployed, ETL said it a few times, and I completely agree, production is everything. If your code is not in production, if it's not in the hands of customers, this is dead value. Until you deploy it, you have gained nothing, you have learned nothing. So we will focus on these through looking at the cycle time. So what is cycle time? Cycle time, and this has been, again, researched, and you can go into more depth in sources like Nicole Forstron's Accelerate book, or look at the DORA metrics. There's a lot of research and empiric evidence showing that focusing on the process through cycle time is one of the key ways to separate elite teams from the rest. So cycle time is about how long does it take my team to deliver a piece of work from the beginning to the end. That piece of work could be a bug fix, it could be a small feature, but any piece of work that my team is able to push from beginning to end quickly, if I can do that and my team can do that repeatedly, small chunks of work, they all reach production quickly, I have a low cycle time and I'm performing better. So you can think about this as like the RPM on the engine in your engineering team. And to better understand how cycle time really captures the entire process, we can look at the main segments in cycle time. So the first segment is coding, and this is basically the developer, typically a single person, sitting in front of the code base and a requirement and building some change. They could be fixing a bug or creating a fancy new feature or refactoring some existing piece of code to make it better. But they're basically proposing a change to the code base based on a requirement. When that phase finishes, now there is a change, typically a pull request or a merge request or similar. And modern teams use code review and similar methods. So I have a change I'm proposing, and now I want someone to take a look at it and give me a code review before we actually merge it. So the next phase is pickup. This is about waiting for someone to take a look at my code, getting someone's attention in the team, getting that person to free up and look at my code. All that time is basically dead in terms of value. Nothing happens beyond waiting for someone to start looking at my code. Once they start looking at my code, we are at the review phase, which is about everything that's needed to be done to review the code, to address the changes and the review comments. Maybe I need to rewrite the entire code again, get the people to look back at my changes after I've made them, maybe get into some argument about are these changes required or not, or they could be wrong, I could be wrong. Eventually, multiple people, at least a developer and one reviewer, but sometimes more, need to agree and push the code to a state where it's ready to be merged, ready to be considered part of the code base, the stable code base. So review will take from the initial beginning of taking a look at my code until my code is merged. And then finally, the deploy phase is about taking that code which was merged and measuring the time it takes until that is actually in the hands of customers. It's in production, and production can vary in many ways for many dev teams. But the key is that now it's actually bringing value. The whole reason I set out to do this piece of work is to get it deployed and put in the hands of customers. Production is everything. And understanding that time it takes the organization to push things to production is crucial. So how do we win with cycle time? How do we take our existing team and improve so that our cycle time becomes lower, more predictable, and we gain all the benefits which I'll discuss? Again, it helps us to look at the different segments. They each have different dynamics which impact the time it takes for each segment. So let's take a look at each of those and see what we need to do to get better at each. So we will start again with coding. A single person sits in front of a requirement and is building a change in the code base. What will affect the coding time and make it longer? First of all, the requirements, they may not be great. And maybe I start coding a new feature and then discover that the requirements are not complete. There are some edge cases which are not defined, or some other things that were not thought through. I need to go back and discuss this with product or whoever is creating the requirements. This is immediately going to impact my coding time and make the time I spend writing this piece of change to the code base much longer. The other thing, so getting better requirements and getting better at having the requirements well thought out before I start coding is a crucial thing for winning at coding. Chopping down the work and focusing on one thing instead of trying to combine multiple things or multiple concerns into a single change, a single PR, is again a crucial skill for the team to learn. If I'm working on a feature, don't fix that bug which happens to be in the code next to the feature you're working on. If you're refactoring something, don't try to push in another feature at the same time. Split the work so that you can focus on something, get it finished, get it deployed, and then do the other thing. So chopping down the work is going to help across the board. And then there are places in the code which are hard to make changes in, and whenever I need to touch those, it's going to take me more time to make sure I'm not making any mistake. It could be a great investment to refactor those away and remove those hard parts of the code so that coding of the next feature becomes much shorter and easier. So that's for the coding phase. Pickup is all about coordination and communication in the team. It's basically waiting for someone to start reviewing my code. So I need to get better, and the team needs to get better at communication, at being aware that things are waiting for people or for anyone to pick up. There are technologies that you can rely on to help you alert the team of things that are waiting for pickup. And again, it's back to communication. It's harder now that we're all remote or semi-remote, but that's how you improve pickup. Another tip that really helps with pickups is what we call deliberate context switching. Developers are typically writing code. They're busy writing their features, working on their own code. Doing code reviews is almost by definition going to require a context switch. So why not be deliberate about it and wait for the context switch that is already happening and decide to do some code reviews at that time. Maybe I'm finishing a meeting, I've just begun my day, I'm back from lunch. These are all great opportunities to take a look at the pickup, take a look at waiting PRs that need to be looked at before I dive into the zone and work on my thing where I do not want to be interrupted. Then the review phase is a little more complex. It has both the coordination side because multiple people need to be involved. The coder, the reviewers, there could be multiple cycles. So a lot of coordination and communication. But to really get better at review, you want to instill a culture where done is much better than started. I know that I really like to start working on cool stuff. I like that much better than I like to finish the task and get them over the finish line and into the hands of customers. So you have to fight that tendency, and as a team, prefer finishing things, getting them over the finish line and into production before starting new things. And review is typically the place where things get stuck. Some teams need to add reviewers. They need to make sure that more people can review other people's code so that they're not a bottleneck, and having a high review part of the cycle time can signal that you have a shortage in reviewers. And sometimes the review will take long because I need to rewrite my code because I did not think it through. I need to do better tech design up front, or get other ways to vet my directions before I invest in coding, only to get a very critical review that will require me to do a lot of rework in my code. And then finally deploy. This is sometimes out of the hands of the direct engineering team, but hopefully more and more teams can impact their future here. So obviously investment in CI/CD and in ways to continuously deliver. You need to invest in your tests, have them more reliable, more comprehensive, so that you are comfortable deploying more often. Having smaller pieces of work highly reduces the risk of deploys and helps you to deploy faster and more often. So those kinds of investments really let you shrink the deploy time, and overall win with cycle time. So some of the benefits that elite teams, the ones that really have cracked cycle time and are able to continuously push value through the cycle, these benefits, I'm going to recount just a few. First and foremost, you have a much shorter learning cycle as an organization. If you're able to push value to production quickly, you can get features in the hands of customers, learn from their feedback and behavior, and repeat. Crucial for startups that are just starting. I think ETL mentioned this. That cycle of getting something, incremental updates to your value and learning back is crucial. The better you are at cycle time and that kind of delivery, the better cycle that you'll have. Having shorter cycle times mean less work in progress, less items that are spread over days and weeks, much less context switches because there are less tasks that are current and active. And by forcing you to have smaller chunks of work also means that you are dramatically reducing the risk of delivery. You're not creating huge bundles of change that now are an integration hell or a delivery risk. You can be much more comfortable releasing all the time. Cycle time can be improved and pretty quickly. Here are some numbers that we have seen from our customers. By starting to look at cycle time, by starting to measure that, and by starting to address the different segments, you are really able to improve. And we've seen improvements of 20, 30, and even 50% of cycle time in a majority of our customers after they start really paying attention. And then finally, metrics or measurements is just the first step. It's a great first step. You have to do it if you really want to get great at software delivery, but it's not enough. So you start with visibility, which is metrics. But first of all, like everything else in life, this is a 80-20 or even a 90-10 case. Most of your pieces of work, most of your branches or your PRs are going to be okay and small and nimble. A few are going to be much longer and will impact your cycle time. So understanding where those problems are and being able to isolate them as a move from metrics to insights. And then the next move is to actually, let's not wait to have a metric and say, okay, we had a problem, how do we improve it? We can bring some of these insights into actions and really let the team interact with the issue as it's before it becomes a large issue. I'll just give one example. If I have a pull request that's waiting in review, it's waiting for someone to pick it up, it's in the pickup phase, we can alert the team and tell them, this is waiting for too long, why don't you pick it up? And by moving from a metric to an action, you're now really able to take it to the next level and reduce your cycle time across all of its segments, automate some of that work away, and really become one of those elite teams that are able to push value day in, day out, like every modern team should. So that's it for me. Invite everyone to join our Dev Interrupted community for dev leaders or listen to our podcasts. I mentioned we just closed a large round and we are hiring. Reach out to me or use the link, a bunch of open positions. And I'm also inviting everyone to start measuring your own cycle time. We are free for small dev teams, so just hit the link to register or reach out to me to learn more. Thank you.
Thanks, Yishai. That was great. Very insightful as well. And now we're going to go to the Q&A panel. I'm going to add everyone to the talk. Hi, guys.
Hey.
Did you have fun?
Yeah,
yep.
Sure.
Awesome.
First time Discord, to be honest. So I hope everything went as expected.
First time's a charm. Okay, so we have some questions from our Discord people. First question is to Yair from Entways. Why do we need the historical background? Don't you believe that, as Sting said, history will teach us nothing?
Well, this sentence by itself doesn't make any sense at all, of course, right? Because no matter what kind of history you're doing, you can learn something from history. So by definition, this sentence doesn't mean much. It's a bit of a trolley thingy. That might sound cute, but it's not serious. So that's my answer to that. What I meant is you don't need to be an historian to understand the things, and I think Yishai and ETL talked about the same concerns. I think the idea is to have a critical, independent thinking. And it's more about asking the right question. For example, why are we using Kubernetes? Why are we using microservices? Why do we want to monitor CPU on each machine that we are running and not checking thresholds on APIs? And saying that sometimes monolith is a good thing. I'm not saying what is good or what is bad. I just want to ask the question.
Okay, cool. And actually continues with the question to ETL. When are you splitting the monorepo?
Yeah, like the monorepo works really good so far. So I don't see it even in the near future. Maybe we'll use like a tool to manage it better, maybe Bazel or something like that when we'll be a bigger company. But like I think both Google and Microsoft are working like monorepo quite heavily. So I think it can scale if you have the right tuning. So yeah.
Okay. Question to Yishai. Okay, I get the cycle time. What are the next metrics I should be looking at?
Yeah, so after you've mastered cycle time, you can go with the additional DORA metrics, things like the deploy frequency, which is, it's a dual to the deploy time and cycle time, understanding how frequently you deploy. You can look at measuring the size of your changes, the PR size or similar, and making sure that you are getting great at cutting down work to small chunks. Or you could focus on things like measuring the quality of the code reviews. We all use code reviews, but there's a wide variety of like, how good is my review process? Is it impactful? Is it actually meaningful? So measuring things like the depths of the review, the number of cycles, the back and forths, who's doing review to who, or to which pieces of the code base. These are all like second level insights that you can go into to really understand what's going on and further improve.
Okay, cool, thanks. Another question for Yair. Can you give an example of a company that didn't really adapt the DevOps culture and concepts, although it had a suitable technology? And also if you have another opposite example as well?
So I can give an example. I can name names, of course, but there were two companies that actually asked from us to do the same thing, basically move from a more monolithic to a more, I would say, microservice-y or Kubernetes cloud native. Both companies got, in a way, what they needed on the technical side. One company just didn't have the right culture. So although they had Kubernetes, and they had GitOps, and they had terraforming, and everything worked really nicely, they actually didn't know how to go to that step. Like, we tried to teach them to do small POCs and to refactor their code, but they had not the capacity on a cultural level to go there. Well, the other company just ate it alive, and we're already doing short increments. So the idea is to move. The technology by itself will not allow you to become high performance, as Yishai says. You need to have something that correlates to that. It's not enough.
Fair enough. Okay, so I think we have a last question for ETL. The technology choices that you mentioned throughout your talk, do you have any thoughts along the way of, okay, this was suitable for us at this point of time, but might not be the best choice for our needs today?
Yeah, I can say that we have a process. We have like some parts of our system that we know they won't scale. Like, it's obvious to everyone. They are not like the best practice. We use like Postgres too heavily on some use cases and so on. So there are areas that we know that they are not, like, they won't scale, and we will change it once we have like the right amount of users or manpower to improve. So there are like things that we know that aren't that good, and we will improve. But a lot more tricky are the things that you feel that work as expected and you don't really talk about them, on a daily basis, and then you ask one of your developers, why did this feature took, I don't know, like a week instead of 2 days? It was, I saw the pull request, it was quite small, like where was the time spent? And he or she answers you like, it was super hard testing it locally because we didn't have the data from production, so I spent 4 days, I don't know, like getting the data from production to test locally. And like, it's to find those areas that no one really thinks about and to see how we can improve. And I can say like, this is a real example. I didn't thought that we have a testing problem until I found out a lot of the feature takes a lot of time because we don't have testing, like good testing infrastructure in place. So those are the tricky parts, not the parts that you say, okay, I know I need to move from Postgres to S3 in a year or so as the database grows. So no process, just like a weekly checkups. Yeah.
Okay, cool. So we don't have any more questions. So I want to thank you guys for being with us. Your talks were very insightful, so thanks for that. And thanks. So thanks, everyone. I was Ila Fish, and I would like to thank you all for being with us. Make sure, please, to answer the survey that we have. This will really help us to understand if we can make an in-person conferences later on. And yeah, I think that's it. Thank you. Bye-bye. Oh, right. Sorry, guys. We have the next meetup. We will really be thrilled for you to be there as well. 20th of April, next meetup. All details are here and also in the meetup.com. Join us. Thank you, guys.